Hi everyone, today I'll talk about the multimeter. The multimeter is a measuring device. It can measure current, voltage, continuity, resistance and gain of a transistor. This multimeter has 3 ports. The first port that we'll be discussing is the common port. The common port is where the black wire goes. This does not change, it will always be here. Okay, this is the common. There's a ground port, as you can say. It's the common port. The red port is used in 2 places. It can be used here when you have to measure currents higher than 10 ampere, at the maximum of 10 ampere and higher than 500 milliampere. Okay, so if you have to measure current of 1 ampere, you have to connect here. If it is more than 500 milliampere, then also you have to connect here. But if it is less than 500 milliampere current, it should be here, and for potential difference it should always be in this port. Okay, so suppose we have a circuit. Suppose we have a simple circuit. There is a wire, a resistance, we have a resistance and a battery. So to measure the potential difference across this resistance, what we do, we have to connect the multimeter in parallel with the resistance and keeping it in the DC voltage configuration. Okay, so it will act as a voltmeter. It's plus minus. So if it is 5 volts, then we get the potential difference of 5 volts. It will be directly connected. I'll show you the circuit. The resistance I'll use is 1 kilo ohm. This here, the 1 kilo ohm resistance. Connected. Any 2 wires, any 2 holes. I'll connect the negative terminal at one of the ports and the other positive and the other port. Now I'll bring the multimeter and I'll put the red here to check the potential difference in the black here, and I'll put this in this parts. Okay, these are the DC voltage measuring part. So this is 600 volt. Okay, if you put it here, you can measure up to 600 volt. Put it here up to 200 volt, after 20 volt, and up to 2 volt, 200 millivolt. I know the power supply, maximum power supply is 5 volt, so I have to keep at the threshold that I have to select should be more than 5 volts. So what I have here is 20 volts, which is more than 5, but I cannot put it in 2 because it is less than 5. Yeah, so I take the 2 wires, negative and positive, and I put them parallel to the resistance. The value is close to 5. Okay, now if you have the same thing here and suppose I put it at 2 volts, it will not show because the maximum is 5. I put it at less than 5. Now if I put it at 200, it will show, but it will not show the rest of the error in the readings. Okay, now I see more error, less error. If I keep at 600 volts, 0, it's like only 5 volts I am shown, not the other errors. Okay, so it's about the significant digits that you can see here, the multimeter readings here. So the next thing that I want to measure is the current. To measure the current, you have to connect the multimeter in series with the circuit. If you have a circuit, then you have to connect in series, just like an ammeter is connected, and it should be in DC amperes. Okay, DC current. Alright, I'll make this circuit, I'll connect it in the series, and we'll see what current we see. Suppose for example, let's do the math. The R is 1 kilo ohm, 10 to the power 3 ohms, and the voltage, I have 5 volts, so I will be V by R is equal to 5 by 10 to the power 3. I should get 5 milliamperes. 5 milliamperes. This is the, so I put it here. Within this is the AC current, sorry, DC current here. So this is 200 microamperes 2 milliamperes, 20 milliamperes. I'll keep at 20 because it should not exceed 20, or else I can keep it at 200 also. Let's see, let's keep it at 200. What I should get is, since I have only 5 milliamperes, so I should get only 5 here with little bit error, sorry, more error, because I cannot see the significant digits. Connect resistance, 1k resistance, negative here, and I will not connect the positive directly here. I'll connect in different place because I have to put the ammeter in series, the multimeter acting as an ammeter. I'll put the negative here with the negative side, or else I'll get a negative value which I'll show. So I keep it. So I see 4.9, 4.8, 5 sometimes. So the values differ. Okay, the more costlier you get, the more accurate values you get. If I increase that 20 milliamperes, then I say 4.96, 4.97. I see that the error is less now. Now I cannot see anything because it is, the value will be more than 2 milliampere. Okay, now if I reverse the polarities, I'll see a negative value, because the current is flowing in this from positive to negative, but my device here is in the other polarity, so I'll have a negative reading. Okay, now we'll check the resistance. Now I know that this is a 1 kilo ohm resistance according to what is written here. Now to check that it is around 1, I'll check it using the multimeter. I'll put the resistance here, and to check the resistance, what I simply do, I take the resistance and I connect the multimeter directly here. It has its own power, it will give the power and it will check the current and the voltage whatever, and it will give us a reading of R using the equation V is equal to IR. It will divide V and I and give us the readings here. This is done by this multimeter, so it's very versatile and very useful in that way. Take this, one of the ports here, the other port here. Now I'll do is I'll put, since I know this is 1k, but you may not know, so let's start with the bigger fish. 2 mega amperes. Okay, 2 into 10 to the power 6. So it can read up to that much value. Since I put it, I see that the value is very less, so maybe it is low. So I lower it. If I keep at 200k, I see it's 1k. Of course it will be 1k. So if I need more error, more significant figures, I'll go down. I say 0.98. Okay, the error is less. So it's like 981 amperes. Sorry, ohms. If I keep it 200, nothing will show because it's definitely 1k is more than 200. So I have to keep at 2k. I'm keeping at 2k. I see that it is 980 ohms. Sometimes in calculations, if it is a good multimeter, sometimes it is good to measure the resistance first, because suppose your calculations are missing, or you have a very you have a circuit where the errors should be very less, then you can take the accurate values using a multimeter. Now let's come to the gain of the transistor. What is gain? Gain is the actually for transistor, the gain is IC by IV, which is the collector current divided by the base current. Now that changes with temperature or the current in the collector, it all changes that way. But for a average value, you can check it here. Like this is a BC547, and I know that its gain is around 300 in average conditions. Okay, so this here is for gain of the transistor. This is an NPN transistor. This lead is the emitter, the middle base, and this is collector. So according to that, I'll put here emitter, base, and collector. Once I put it, look at the value what I get, around 300, yeah, 336. Okay, 336. These are the values of the gain of transistor. If you have different transistor, you will get different values. Now let's see the last thing, which is the continuity. Okay, now the continuity is to check a breakage in wires, or if a diode is conducting, or if you see if the diode is destroyed, because if its reverse bias is completely conducting, then it is destroyed. In specific diodes, not every diode. So if I connect these 2 points, you see that sound? That is the sound of continuity. Now if I have a wire, this is a simple wire, and I connect one port to the other, see, I hear a continuous. That means this wire is okay. Now suppose we have an LED. Check if the LED is broken or not. You can check it using continuity. See, it's lighting up. It's okay. Thank you for watching. I'll be making more videos of electronics, and I hope I can also learn through it. Thank you.